It's amazing how AI is transforming our lives today, right? Everything we see today, the reasoning models, the AI agents, etc., they're all running on the data center. Well, they are going to come from the data center to our pocket sometime very soon. We're all amazed by what AI is able to do today. However, a lot of what the AI that we see being used today is developed and actually run on the cloud. If you look forward as AI models become more efficient on smaller models and the edge solutions like ours become more energy efficient, several of these applications that we are amazed by that's happening on the cloud will actually come to the edge. Because the models are developed on the cloud, deployment on the edge has three key challenges. You don't have the power and performance freedom that you have on the cloud on the edge. So the three key factors really are: first is to be able to get to the accuracy and ease of use that the customers have when it is on the cloud. Second is you have unlimited capacity in terms of performance on the cloud, which you don't have on the edge. And the third is really the power performance constraint of edge device. You just can't get a liquid cooling that you have available at a data center. So Memory-X, with its unique solution and architecture, actually addresses all three in terms of ease of use. We have 1,000+ models that are running on our hardware with no need for compression, pruning, or quantization. So what you train is what you get during inferencing. Our power performance is about 10x compared to a GPU. So you're getting the performance of a GPU without paying the power penalty, and much better than a CPU or an NPU. So right from the beginning, we focused the company on AI. But for everything else that is critical for the silicon to be designed, both the silicon and the systems, actually, we partnered with Cadence. Memory-X AI is an accelerator, and so it connects to a whole bunch of host systems out there, whether it's a Windows-based system or a Linux-based system or an Android-based system, and whether it's an x86-based system or an ARM-based system. Because the accelerator has to work across all of these platforms, the USB and PCIe are critical components that really allow our chips to connect and talk to these hosts. So Cadence provides us these IPs that are not only area and power efficient, but also silicon proven and certified for deployment. We use Cadence PCI Gen 3, USB Gen 3 and 2, and this has allowed us to go to market with these IPs without having to develop them in-house. We use these across all platforms, Windows and Linux and Android. We use Xcelium and vManager for our IP level and SoC level verification. Very important to make sure there are no bugs in the design. And then we use Genus from RTL to a netlist synthesis. Genus helps us get the best implementation of the RTL in terms of power and performance as you implement the design into a GDS. So yeah, these tools are very critical in our silicon design. We use Allegro for our system design. We design our own bring-up boards. We design our production M.2 modules. On the production M.2 modules, it's 22 millimeters by 80 millimeters, so really tight, and we put 4 of our chips on them. So it's very critical that you can put all the chips there and all the surrounding chiplets with it, and then of course all the wiring. So Allegro helps us really have a very compact design possible with 4 of our chips on an M.2 module. Cadence and Memory-X have been a partner since day one, since our inception really. Cadence provides us the best-in-class IPs, best-in-class design tools, and Memory-X focuses on AI. And really the two of us together can work and bring the best-in-class AI products into the market.